So the first thing that we'll do is we'll establish this basic rangefinder or proximity test for our enemy AI. And I'm just going to block this out by creating a new cube. And this cube is going to represent the enemy game object, or more appropriately, kind of some of the enemy geometry. It's a best practice really to put this enemy inside an empty game object so that we could swap out elements within it. So I'll establish this container right off the bat. So I'll create an empty game object, and I'll call this, for now, we'll call this enemy with AI. And I'll take this enemy game object and drop it inside the enemy AI with AI. Now this enemy, this is probably more appropriately the enemy's geometry or enemy game object or enemy body. And I'm going to put some other elements within this object just so that we kind of get a sense of the orientation of this object when we're inside our game window. But before I do, I'm going to apply a material to the enemy body just to give it a little bit of contrast. So I have a materials folder where I have some really basic materials, and I'll throw kind of a dark material on the enemy body. And the next thing I'm going to do is I'll just borrow the enemy body and duplicate it. But I'm going to make this much smaller. So maybe I'll make it 0.5. I'll scale this down to 0.5. And I'll move this in the direction of Z and sort of snap. And I'm going to add a different material. And I'm going to call this enemy front or forward. This is just kind of a visual cue to remind me of the forward direction of the enemy. So as it's wandering around, if I have just a simple cube, it could be a little disorienting. So I'll just take this little red material that I have here and throw it on the enemy. And so now we have an enemy and we know the direction that it's pointing. Okay. So the next thing that we're going to do is I'm going to create a player object. So we're just establishing our basic references, and just to provide some contrast, I'll create a sphere. And this sphere, I'll call it player, and I'll throw another material on the player just to give it a little bit of contrast. And just so that I have some other additional visual cues, I'm going to change the tag of the player and assign it with this player tag. So I get this little widget that pops up. I'll do the same thing with the enemy AI object. And just add these little tags here so that we can see them a little bit more clearly. So one of the things that we're going to need to do is create some kind of proximity awareness. Now, I'm going to do this on separate game objects. We could combine all of this into one game object and have different state machines, or in fact, in some cases, we could combine all these different state machines. But I like to kind of really chunk out or break out the logic or the functions that we're creating into these small, manageable little routines. They'll be much easier to troubleshoot, and we can identify these things pretty quickly. So the first thing that I'm going to do is I'm going to create an object that's going to represent the range or the rangefinder for my enemy. And I could use really any object to do this, but because I'm going to set this up as a trigger, I want either a sphere or a sphere collider to represent the area that the enemy should be aware of the player. And so I'm going to use either a sphere or maybe I'll use a cylinder in this case. It'll give me kind of a decent visual aid here. So I have a capsule collider on the cylinder. I'm going to resize this a little bit here in a moment, but I'll just call this, this is the enemy range finder, or I could just simply call it range, or range finder, so as not to confuse it. So we have that inside the enemy AI. We have the range finder. I'm going to scale the Y way down, so I'll make this 0.2. I'll make it much bigger. On the X, we'll make it 10 meters, and on the Z, we'll make it 10 meters. For now, we can adjust this later. I'll make the cylinder a little bit flatter, and so we have this this capsule collider that's acting. We'll use this as a trigger in a moment. But this cylinder will represent the area with which we should be aware. So I'm actually going to make this a little bit bigger for testing. I'll bump this up to 20. So I'm going to take this rangefinder and I'm going to apply a material. Now this is unnecessary. We could actually just simply get rid of the mesh render because we're only interested really in the collider here. But as a visual aid, I'm going to flip on the mesh render, and I've set up this proximity material, and I'll just throw that on the rangefinder. And this is just it's a material. I've chosen a color, and I've adjusted the alpha. So we're using the render mode of transparent, and then we can set this to whatever color we want. Okay, and this is just kind of a little visual cue to let us know what the range of the enemy is. Okay, so I have this rangefinder set up. Looks pretty good. That'll be pretty clear if the player ends up inside that. So this rangefinder, I'm actually going to use this to detect, to assign my state machine and any logic that's associated with it. So I'm going to right click and add a state machine. And it's really important. We're going to have multiple state machines that are running underneath our enemy AI. And it's really important that we name our state machines and stay organized. So I'm going to call this FSM enemy range. Now we could name these state machines through the FSM tab. We could also go over here to the component and rename the component that's been assigned. I like using this FSM tab. So this is going to be a simple two-state machine. We're going to have a state when we are player is out of range. So we'll call this out of range, and I'll right click and add a state. And this is when the player, or the target more accurately, is in range. And so we're simply just going to listen for some trigger events, whether we're in or out of this, this trigger, to determine whether we're in or out of range of this object. Now, I want to use a trigger event. I don't want to use a collider, because if this were a collider, then the enemy is going to bounce off of this, this collider. So I want to make sure that I select my rangefinder, go find the capsule collider, and make sure that it's set to trigger. I'll then go down into the state machine, and for out of range, I'm going to listen. I'm going to establish an action. Just do a quick trigger event. So I'll search for trigger event. That can be found in the physics category, and we'll add a trigger event. So currently, if we start, we'll assume that the player or the target is out of range. Okay. So if we're out of range, we'll listen for an on trigger. For now, we'll listen to on trigger enter, but we'll modify this a little bit. We do want to filter based on a tag. So right now, all the elements within the environment, anything that's untagged, will be determined that it's in range, and we only really want to focus on the player for now. Now we can refine this and make this more sophisticated, but we want to filter based on the player. So we'll use tags. Now in order for this to work, we got to make sure that our player object is in fact tagged with player. I'll go back to the rangefinder here. So we're listening for on trigger enter with player. And if we get that condition, we'll fire off a send event. So I'll create a new event. Now this is going to be a simple loop between two states, and so I'm going to use just a generic next event, and we'll pass that to in range. So if we're in range, we're going to listen for a trigger event, and we're going to filter based on player, but we're going to listen not for whether the player is entering the range, because if it ends up here, we know that we're already in range. We are going to listen to on trigger exit to see if it exits our range. And if so, we'll borrow this same next transition. If we need a different transition event, we'll create one. But right now we got a simple loop. So we're testing for if we're out of range, and then if we're in range. So I'll hit play and we'll test and see if this works out. So I want to test this. I want to move the player around, and right now you can see that we're out of range, so we're probably not going to detect our player moving in and out. We'll squash that bug in a second. But before we do, I want to be able to select my player. But when I do, I'm going to lose focus of the Playmaker editor, and I want to use that for my debugging here. So I'll make sure that I select my rangefinder. I'll hit the lock button in the Playmaker editor, and that'll allow me to select my player. And I'll grab the player and I'll kind of move this around. And so what I'm hoping will happen is that as the player moves in and out of this trigger, it's going to switch back and forth between out of range and in range. But what we're bumping into here is that the player is not getting detected by this trigger event. I think we have a collision matrix issue happening here. In other words, we have a static collider that's interacting with another static collider, and if we were to check the collision matrix, we might find that that is kind of an invalid. We're not getting any feedback, or we're not getting any events passed to Playmaker, and so we can fix that by selecting our player, and we're going to add a rigid body to it. So we'll go to Components, Physics, Rigid Body. Once we do that, that should solve the problem, but I still want to be able to drag this thing around. I actually don't want this sphere to kind of fall to the ground and bounce and roll around. I want to be able to pick it up and drag it and not create any wonkiness with the physics engine. So what I'm going to do is I'm temporarily going to select my player object. I'm going to go to the rigid body, and I'm going to make sure that it is kinematic. So I'll check is kinematic. And if we have a rigid body that's kinematic, you'll see that it no longer talks to the physics engine for movement, but we get the advantage of having trigger and collision interactions by this object. And so you can see that I'm dragging the player, I'm outside the range of this trigger. Now I'm inside. And you can see there's a kind of maybe a little glitching going on here, and I think we can iron that out. Currently, our logic is set up on our rangefinder that the trigger event is listening for an on enter. And that's just kind of a split second entering our collider here. And I think something that's going to be a little bit more absolute, a little bit more reliable, is to listen for on stay, on trigger stay. So are we inside the collider? Are we staying inside the collider? If we are no longer staying, as we exit, we'll end up in out of range. Okay, so we'll test that really quickly. So we're currently out of range. Now we're currently in range. Out of range, in range. Out of range, in range. Okay. One other thing that I'll do while I'm here, just for debugging, is I'm going to set out of range. I'm going to set the color to red. I'll set the in range color to green. And that'll help with just kind of the visual debugging of this rangefinder. Okay, so that basic functionality works. Now we're going to pass this information a little bit later up to our enemy to determine, to set a bool that will be tracked by the parent object, the owner of this. But right now we got the basic function working, and we'll utilize that information a little bit later. So in the next presentation, we're going to tackle the field of view, which is going to be a little bit more complicated. There's going to be a lot more actions involved, and we'll have to determine some basic strategies here. There's going to be a lot of different ways to do this, but I want to boil this down to kind of the simplest way that's scalable, that'll solve all of our problems, and it'll be fairly intuitive. But we'll do that in the next presentation.